Artificial intelligence goes for beginner by knowledge and information. In this video we are discussing about object detection. Object detection is a computer vision task that involves identifying and locating objects within an image or video. The goal of object detection is to create a bounding box around each object and label them with the corresponding class or category. This task is more complex than simple image classification because it requires the ability to detect multiple objects in a single image, and to distinguish between objects that may have similar shapes or appearances. There are several techniques for object detection, including 1. Deep learning-based approaches. These involve training convolutional neural networks, CNNs, on large datasets of labeled images. Examples of deep learning-based object detection algorithms include faster RCNN, YOLO, you only look once, and SSD, single shot detector. 2. Traditional computer vision-based approaches. These involve using handcrafted features and algorithms to detect objects. Examples of traditional computer vision-based object detection algorithms include Haar cascades and Hog, histogram of oriented gradients. Object detection has numerous applications, including autonomous driving, surveillance, face detection, and industrial automation. Object detection has become an important area of research in computer vision due to its many practical applications. For example, in the field of autonomous driving, object detection algorithms can help vehicles detect and avoid obstacles on the road. In the field of surveillance, object detection can be used to identify and track people and vehicles in a given area. In the field of industrial automation, object detection can be used to detect and classify products on a manufacturing line. One of the major challenges in object detection is the ability to detect objects in real time, especially in videos where objects may be moving rapidly. Another challenge is the ability to accurately detect objects in complex environments, where there may be occlusions or objects of similar shapes and sizes. To address these challenges, researchers continue to develop and refine object detection algorithms, incorporating new techniques such as attention mechanisms, feature pyramid networks, and anchor-free detection. Additionally, advances in hardware, such as the development of specialized graphics processing units, GPUs, and tensor processing units, TPUs, have enabled the deployment of object detection algorithms in real-world applications. One of the recent trends in object detection research is the use of deep learning-based approaches, particularly convolutional neural networks, CNNs, which have shown state-of-the-art performance on a variety of object detection tasks. These deep learning-based approaches typically involve a two-stage process, where a set of proposals or regions of interest, WA, are first generated, followed by a classification and regression step to refine the proposals and predict the final object detection results. Another recent trend in object detection research is the use of attention mechanisms, which allow the model to selectively focus on the most informative regions of the image, rather than processing the entire image. This can significantly improve the efficiency and accuracy of object detection algorithms, particularly in complex environments. Anchor-free detection is another area of active research, which aims to eliminate the need for manually defined anchor boxes, which can be time-consuming and difficult to tune. Instead, anchor-free detection methods directly predict the bounding boxes and objectness scores without the need for predefined anchor boxes. In addition to these technical advances, there is also increasing interest in ethical and social considerations in object detection, such as issues related to privacy, bias, and fairness. As object detection continues to be deployed in real-world applications, it is important to consider the potential impact of these systems on society and to develop methods for mitigating any negative effects. Object detection is a computer vision technique that involves identifying and locating objects of interest within an image or video stream. It is a complex task that involves multiple stages, including image pre-processing, feature extraction, object localization, and classification. There are several popular methods for object detection, including the following. 1. Haar cascade classifiers. This method uses a machine learning algorithm to identify features that are common to a particular object, such as the edges and corners of a face. 2. Viola-Jones Object Detection Framework. This method uses a similar approach to the Haar cascade classifiers, but uses a more advanced feature extraction technique known as integral image. 3. RCNN, Region-Based Convolutional Neural Networks. This method involves training a deep neural network to identify regions of an image that are likely to contain an object. The network is then used to classify these regions and generate bounding boxes around them. 4. YOLO, You Only Look Once. This method uses a single neural network to predict the class probabilities and bounding boxes of objects in an image. Object detection is used in a wide range of applications, including autonomous vehicles, surveillance systems, and image search engines. Object detection is a crucial component of many computer vision applications, including those that involve image and video analysis. For instance, object detection can be used in medical imaging to locate and identify specific organs or tumors, in agriculture to identify pests or damaged crops, and in robotics to enable autonomous navigation and manipulation. One of the key challenges in object detection is achieving high accuracy while minimizing false positives and false negatives. This requires selecting appropriate models, training data, and parameters, as well as careful tuning and optimization. Another challenge is dealing with complex scenes and occlusions, where objects may overlap or be partially hidden from view. To address this, advanced object detection methods may incorporate multi-stage processing, fusion of multiple sensor modalities, or 3D reconstruction techniques. In recent years, there have been significant advances in object detection algorithms, particularly those based on deep learning. One of the key advantages of deep learning-based approaches is their ability to learn features directly from raw data, without the need for handcrafted feature extraction. Some of the most popular deep learning-based object detection architectures include Faster RCNN, Mask RCNN, and RetinaNet. These models use a combination of convolutional neural networks, CNNs, and region proposal networks, RPNs, to generate candidate object regions and classify them. Other recent developments in object detection include the use of attention mechanisms, which enable the model to focus on the most relevant regions of an image, and the integration of object tracking algorithms, which enable the model to follow objects over time. Object detection also plays a critical role in the development of self-driving cars and other autonomous systems. These systems use multiple sensors, including cameras, LiDAR, and radar, to detect and track objects in their environment. Object detection algorithms are used to analyze the sensor data and identify obstacles, pedestrians, and other vehicles, enabling the system to make informed decisions about how to navigate the environment. Another important aspect of object detection is the availability of large annotated datasets. These datasets are essential for training and evaluating object detection models, and they typically require significant human effort to create. Some of the most popular object detection datasets include COCO, Common Objects in Context, Pascal VOC, Visual Object Classes, and ImageNet. To address the challenge of data annotation, there is ongoing research into developing more efficient and accurate annotation tools, as well as exploring alternative approaches such as semi-supervised and unsupervised learning. In addition, there are ethical considerations associated with the use of object detection in applications such as surveillance and security. There are concerns around privacy, bias, and discrimination, particularly when these technologies are used to monitor and control populations. To address these concerns, there is a growing interest in developing ethical guidelines and frameworks for the use of object detection and other AI technologies. These efforts aim to promote transparency, fairness, and accountability in the development and deployment of these systems. Overall, object detection is a dynamic and rapidly evolving field with many exciting developments, numerous technical and ethical challenges, and exciting potential applications. That is driven by advances in deep learning, computer hardware, and data annotation tools. As more data becomes available and algorithms become more sophisticated, object detection is likely to play an increasingly important role in a wide range of industries and applications, with significant potential for impact in a wide range of applications. Ongoing research is focused on improving the accuracy and robustness of object detection algorithms, as well as extending their capabilities to more complex scenarios and environments. In conclusion, object detection is a complex and rapidly evolving field with significant potential for impact in a wide range of applications. Ongoing research is focused on improving the accuracy and robustness of object detection algorithms, as well as addressing the ethical considerations associated with their use. In next video, we will discuss about image classification. Thanks for watching. Please like, share and subscribe.